video on sampling distributions for proportions. In the last video, we came up with a general expression for the confidence interval. Here we're going to apply it to an example. So in this particular example, we're looking at Pharrell Williams. I feel like I should have some of his music playing in the background. And they tell us, instead of looking at the many songs he's been involved in, we're going to take a look at a random sample of 80 of his songs. And out of those 80, 10 were either nominated for an award or won an award. So here it says our goal is to estimate the proportion of all the artist's songs that have either been nominated for an award or actually won the award. So here, when we're talking about the proportion of all, that's telling me I'm trying to find an estimate for P. Get an estimate for P, that population proportion. And I'm going to do that using this sample of 80 songs. So first question, the first thing we're looking for is what is the point estimate? So I want to estimate P, the proportion for the entire population of his songs. I'm going to do that based on my sample of 80. My point estimate is going to be P hat, the proportion from the data I actually have. So I've got my sample of 80, and out of those 80, 10 meet the criteria of actually winning an award or being nominated for an award. And if you work that out, you get 0.125. Okay, so based on my data, 12.5% of those songs have been up for an award. I know that if I took a different 80 songs, we're not going to get 12.5% again. Maybe I'll get 9%. Maybe I'll get 15%. Who knows? Okay, but different samples are going to give me different point estimates. So that's why this is just part one of the problem. We've got to keep going here. Next part, asking about the standard error of the point estimate. So I know different samples are going to give me different estimates here, not 12.5 every time. So let's see how much that's going to vary by. So that's our standard error term, and that's our square root of P hat times 1 minus P hat all over our sample size. All right, and our sample size, again, we're looking at a sample of 80 of his songs. If we calculate that, you should get something like 0.0370, again, rounding to 4 decimals here, just so we all stay consistent. So 0.0370. So one sample gave me 12.5% were nominated for an award. I would expect that to vary by about plus or minus 3.7%. All right, let's start putting it all together now. There's one more piece of information that I need. If I want to be 95% confident, I need to get that multiplier that gives me that level of confidence. And then I'm also asked to find the margin of error. So 2 parts to this question. Let's check out the first, 95% confident. So normal distribution still playing a huge role because we're assuming the P hats are normal based on what we've talked about earlier. So centered at 0, there's our standard normal. When we're saying 95% confidence, we can think of that as having 95% of the area in the middle of the distribution. And then that would give us 5% left over. Or if we split it equally on either tail, I've got 2.5% on either side. And we know how to find the z-scores that give us this kind of breakdown. Remember, when we know a percentage and we're looking for a z-score, that's inverse norm on our calculator. So just as a reminder, I'm going to say z is equal to inverse norm. And if I'm trying to find this z-score, I need to put in the percentage to the left or below, so that's this 2.5%. So inverse norm of 0.025. If you do that and round to 4 decimal places, you should get negative 1.96. Then on the right-hand side, if you do the same thing with that, we don't even have to use our calculator. We can, because this guy is symmetric around 0, we know this guy's going to be positive 1.96. But just for practice and to make sure we're understanding how this is working, if we use inverse norm, the value that we should supply here is the area to the left. So that's 95% plus the other 2.5%, or 0.975. All right, so we've got this breakdown with 95% in the middle, 2.5 on either side. The z-scores that make that happen in the standard normal case are plus or minus 1.96. Our multiplier, to answer the first part of the question, is going to be z star. And we're going to always use the positive version of that z-score here. So z star of 1.96 for our multiplier. All right. The second part of the question is asking for the margin of error. So remember, our margin of error, MO for short here, is that piece that we're adding and subtracting to the point estimate. And it had our two parts, the multiplier and the standard error. So the multiplier we just found out was our 1.96. The standard error we found out in the previous part was the variability that we can expect from sample to sample, this 0.0370. And all we have to do is multiply these guys together to get our margin of error. When you work that out, you should get 0.0725. Okay, so we've answered both parts of our question here. We've figured out our multiplier that gives us 95% confidence was 1.96. Always make sure you use the positive version of that z-score. The margin of error is 0.0725. So now we're finally putting it together, asking us to construct the confidence interval. So remember, our confidence interval started with just our estimate based on our data, our point estimate. So in this case, it was that 12.5%. We know that's going to vary from sample to sample, and we need to attach a level of confidence, so that's where our margin of error piece came in. So plugging in our values here, point estimate based on our data, we got 12.5%. The margin of error we calculated was our 0.0725. And when a lot of places you'll see it just left like this, is reporting their confidence interval. We would like you guys to actually write it out as an interval, to go one more step to do the math. So when you do this, always subtract first. Put the smaller number first, just like on a number line, smaller numbers on the left. So 0.125 minus the margin of error, and then 0.125 plus the margin of error for the upper end point. Doing this, you should get 0.0525 for your lower end point, and the upper end point should be 0.1975. Okay, so you have our confidence interval. Doing all this math isn't any good. It's not useful to anyone unless you can explain what this means. So remember our original question here. The original goal was to estimate P, the proportion of all of his songs that have been up for an award. We said based on one data set, we got 12.5%. We know that's going to vary by about 3.7% each sample I take. We found a value that it gave us our attached level of confidence to this estimate, and we came up with an interval that was centered around that 12.5%. So let's interpret this here. For the interpretation, make sure you're actually writing out a sentence. Interpret means interpret, don't do any math. I'm going to be looking for three things. First thing is just state how confident you are. So I'm going to say we are 95% confident. And if you like to be more formal, you could say something like this study is 95% confident. But I'm going to go informal. So that's part one. State how confident you are in your estimate. Part two is say what in the world you're trying to estimate. Put it in context. So we are 95% confident. This is supposed to say confident. Sure doesn't look like it. There we go. Confident. So say what we are trying to estimate. In this case, we're trying to estimate the true proportion, the population proportion. So I'll say the proportion of all. I'm going to emphasize all here to say I'm talking about the population. The proportion of all his songs up for an award. And then lastly, give your estimate or your range here. So I'll say is between our 0.0525 and the 0.1975 from the previous question. Okay, so again, looking for three different parts here. One, how confident you are. Two, put in context what you're estimating, population proportion. And then three, just give that estimate, give your range for that. I want to have you guys put a little note off to the side here. Do not use the word data in this interpretation at all, anywhere. So say, do not say data or sample. Okay, we're not estimating anything about the data. The data will always be right in the middle of our estimate. That we construct our estimate around the data. So for example, this 12.5 is right in the middle. The data will always be in the middle. We're 100% confident the data is in the middle. So don't say anything about data. We're estimating the population proportion. Then the last question, just use your intuition here. Your friend thinks he loves Pharrell Williams. Maybe he thinks 50% of his songs have been up for awards. Based on our interval, does this seem valid? Probably not. We're 95% confident. It's somewhere between 5 and 20-ish%, which does not include your friend's guess of 50%. So I'll just say no, 0.5 is not in our 95% confidence interval. All right, this concludes our first example broken down into steps. I'd like for you guys to go to the next pages, try those examples on your own, and then check out video 3 to test your work and make sure you did that correctly.